On February 14, 2025, the Event Horizon Telescope detected something that should be impossible. Sagittarius A, the supermassive black hole at the center of our Milky Way galaxy, began pulsing. Not the random flickers astronomers had observed before, but regular rhythmic pulses occurring every 22 minutes with precision that exceeds the accuracy of atomic clocks. For 4 million years, this cosmic monster has sat relatively dormant at our galaxy's heart, a gravitational anchor holding 26,000 light-years away, occasionally flaring when gas clouds wander too close. But in early 2025, something changed. The black hole that has been silent throughout human history suddenly developed a heartbeat. And it's not alone. Within weeks of detecting the pulses from Sagittarius A, astronomers identified similar rhythmic patterns from supermassive black holes in 47 other galaxies, all pulsing, all synchronized, all operating on cycles that matched no known astrophysical process. The pulses aren't random variations in accretion. They're coordinated, as if these cosmic titans spread across billions of light-years are communicating with each other. But the pulses are only the beginning. Because when scientists analyzed the patterns in detail, they discovered something that has sent shock waves through the astrophysics community. The pulse sequences contain information. Mathematical progressions, prime numbers, geometric patterns. The black holes aren't just pulsing randomly, they're transmitting data using a language based on universal mathematical constants. And most disturbing of all, the transmissions are getting stronger, more complex, more frequent. Whatever is happening with these black holes, it's accelerating, building toward something. The question is no longer whether black holes are more than simple gravitational wells. The question is, what are they really, and what are they preparing for? If you're ready to discover what's really happening with black holes in 2025, stay with me, because what astronomers have found in just the past 9 months challenges every assumption we've made about these cosmic phenomena and suggests that the universe operates according to principles we've never imagined. The Event Horizon Telescope, the global network of radio observatories that captured the first image of a black hole in 2019, maintains continuous monitoring of several supermassive black holes, including Sagittarius A. On Valentine's Day 2025, Dr. Shep Doleman's team at the Harvard-Smithsonian Center for Astrophysics noticed an anomaly in the real-time data stream. We were conducting routine monitoring when the signal amplitude suddenly increased by 340%, Dr. Doleman reported in an emergency press briefing on February 16th. Not a gradual brightening over hours or days, but an instantaneous jump. One moment, Sagittarius A showed its normal baseline emission. The next moment, it was dramatically brighter. The brightness surge lasted exactly 22 minutes, then dropped back to baseline, just as suddenly. The team initially suspected instrumental error, perhaps a data processing glitch or calibration problem. But multiple telescopes in the EHT array recorded the same event independently. When Madrid, Chile, Hawaii, and the South Pole all show identical signals, you know it's real, Dr. Doleman stated. 22 minutes after the brightness returned to normal, it surged again. Same amplitude increase, same 22-minute duration, then baseline, then another pulse. Dr. Sarah Chen, an astrophysicist at Caltech who analyzes EHT data, recognized immediately that this wasn't normal black hole behavior. Supermassive black holes do vary in brightness as they consume matter. But those variations are chaotic, driven by turbulent gas dynamics, magnetic field reconnections, and other stochastic processes. This was different. The regularity was unprecedented. The timing precision was impossible. The pulses continued throughout February 14th and 15th. The EHT team called in experts from around the world. By February 16th, every major radio telescope on Earth had turned toward Sagittarius A, documenting the phenomenon in detail across multiple frequencies. The 22-minute period remained absolutely constant. Measurements showed variations of less than 0.01% precision that exceeded the stability of the atomic clocks used to coordinate the observations. Natural astrophysical processes don't work this way, Dr. Chen emphasized. Gas orbiting near a black hole experiences relativistic beaming, time dilation, and chaotic turbulence. Even if some process could create periodic emissions, maintaining that period to microsecond precision over days is physically impossible, unless something is actively controlling it. While the world's attention focused on Sagittarius A, astronomers conducting routine observations of other galaxies began reporting similar phenomena. On February 18th, the supermassive black hole at the center of M87, the galaxy 55 million light-years away, whose black hole was famously imaged in 2019, began pulsing. Dr. Kazunori Akiyama, who led the M87 imaging campaign, was stunned. M87's black hole has been relatively stable since we started monitoring it intensively. Seeing it suddenly develop the same pulsing behavior as Sagittarius A was shocking, but what really got our attention was the timing. M87's pulses occurred every 83 minutes, not 22 minutes like Sagittarius X. At first, this seemed to rule out any connection between the two events. But Dr. Marcus Webb, an astrophysicist specializing in black hole physics at Princeton, noticed something extraordinary when he compared the pulse periods. The ratio of the periods is almost exactly 3.77 to 1, Dr. Webb calculated. That's very close to the ratio of the black hole's masses. Sagittarius A has a mass of about 4 million solar masses. M87's black hole is roughly 6.5 billion solar masses, about 625 times more massive. But when you account for relativistic effects near the event horizons, the relationship between pulse period and mass follows a precise mathematical formula. The formula suggested that pulse period wasn't arbitrary. It was determined by fundamental properties of each black hole. And if that was true, other black holes should also be pulsing at rates proportional to their masses. Over the following week, astronomers surveyed every supermassive black hole they could observe with sufficient sensitivity. By February 28, 2025, the count had reached 47 black holes showing rhythmic pulsing behavior. Each pulse period correlated precisely with the black hole's mass according to the formula Dr. Webb had derived. It's as if someone threw a switch, Dr. Chen said. 47 black holes across the observable universe, ranging from 100,000 to 20 billion solar masses, all suddenly activated synchronized pulsing behavior following the same mathematical relationship. The probability of this occurring naturally is effectively zero. As more data accumulated, researchers began analyzing the pulse patterns in detail. While the period of pulses remained constant for each black hole, the amplitude, the brightness of each pulse varied in complex patterns. Dr. Elena Vasquez, a signal processing expert at MIT, brought in to analyze the data, recognized structure in the amplitude variations. I've spent my career working on communication systems, and information theory. When I looked at the pulse amplitude sequences, I immediately saw encoding. These aren't random fluctuations. They're modulated signals carrying information. The first pattern Vasquez identified was simple: sequences of high and low amplitude pulses that represented binary code, ones and zeros. Within this binary framework, she found repeating sequences that corresponded to prime numbers 2, 3, 5, 7, 11, 13. Prime numbers are mathematically fundamental, Vasquez explained. They can't be divided by any number except themselves and 1. Any intelligence anywhere in the universe working with mathematics would recognize primes. It's the universal hello, a way to say this signal is artificial, created by something that understands math. But the transmissions went far beyond simple primes. Deeper analysis revealed sequences encoding pi, the mathematical constant 3.14159, calculated to hundreds of decimal places. Other sequences encoded e, the base of natural logarithms, and the golden ratio phi. These aren't approximations, Dr. Webb noted. The values are precise to the limits of our measurement capabilities. Whatever is generating these signals has perfect knowledge of fundamental mathematical constants and is deliberately encoding them into the pulse patterns. Most remarkably, the 47 pulsing black holes weren't transmitting identical messages. Each black hole broadcast different mathematical sequences, but the sequences were related, like different chapters of the same book or different instruments in the same symphony. Dr. Jennifer Torres, a mathematician at Stanford who joined the analysis team, discovered the relationship. When you arrange the 47 black holes by mass and align their transmissions chronologically, the mathematical sequences form a progression. The smallest black hole transmits basic arithmetic operations. Larger black holes transmit more complex mathematics, algebra, geometry, calculus. The most massive black holes are broadcasting what appears to be higher dimensional mathematics we're still struggling to interpret. It was as if the black holes were collaborating on a single, enormous mathematical textbook, with each contributing the chapter appropriate to its size and capabilities. While radio astronomers tracked the pulsing behavior, another group of researchers made a connection that deepened the mystery. Dr. Robert Malhotra, a quantum physicist at CERN, noticed similarities between the black hole pulse patterns and phenomena observed in quantum entanglement experiments. We've known for decades that black holes and quantum mechanics have a strange relationship, Dr. Malhotra explained. Black holes have entropy, a measure of information content that scales with their surface area, not their volume. Stephen Hawking showed that black holes emit radiation through quantum processes. The connection between gravity, information, and quantum mechanics is fundamental but poorly understood. Malhotra proposed a radical hypothesis. The pulsing black holes might be exploiting quantum entanglement on cosmic scales. If quantum information can be entangled across vast distances, and we know it can in laboratory settings, then perhaps black holes separated by billions of light years could be quantum mechanically connected, able to coordinate their behavior instantaneously despite the light speed limit. This would explain the synchronized activation of all 47 black holes within a 2-week period in February 2025. If they were quantum entangled, a change in one could instantaneously affect all others, regardless of distance. To test this hypothesis, Malhotra's team predicted specific correlations that should appear in the pulse patterns if quantum entanglement was involved. In March 2025, analysis of accumulated data confirmed several of these predictions. We're seeing correlations that shouldn't exist, Malhotra reported. When Sagittarius A emits a particular pulse sequence, M87's black hole responds with a complementary sequence within minutes, far faster than light could travel between them. The only explanation consistent with known physics is quantum entanglement. But quantum entanglement typically involves individual particles or small systems. Extending it to objects with masses of millions or billions of suns requires physics beyond our current understanding. Either we're witnessing new physics, Malhotra stated, or something with advanced understanding of quantum mechanics is using black holes as nodes in a galaxy-spanning quantum communication network. As spring 2025 progressed, the black hole pulses grew stronger and more complex. What began as simple periodic brightness variations evolved into intricate patterns involving multiple frequencies simultaneously. Dr. Doleman's team documented the evolution. In February, we observed single-frequency pulses. The brightness went up and down at one rate. By March, we detected harmonics, additional pulse components at frequencies that were exact multiples of the fundamental rate. By April, the signals had become polyphonic, with 5 or 6 different frequencies modulated independently. The increasing complexity suggested accelerating activity, like a machine warming up or a system preparing for a major operation. Dr. Chen analyzed the energy output. The total power radiated by these pulsing black holes has increased by a factor of 10 since February. That represents an enormous energy increase, equivalent to millions of supernovae worth of energy being generated and somehow organized into these structured signals. Where was this energy coming from? Black holes can release energy by converting matter falling into them into radiation through accretion processes. But the observed power increase required matter consumption rates far exceeding what observations showed. We're not seeing proportional increases in accretion, Dr. Chen noted. The black holes aren't consuming more visible matter. Either they're feeding on something we can't detect, dark matter perhaps, or they're extracting energy directly from space-time itself through quantum processes. The latter possibility connects to theories about black hole energy extraction proposed by physicist Roger Penrose in 1969. Penrose showed theoretically that energy could be extracted from a rotating black hole by exploiting the ergosphere, a region outside the event horizon where space-time is dragged along by the black hole's rotation. If something has mastered Penrose process energy extraction on cosmic scales, Dr. Webb suggested, these black holes could be power plants, converting rotational energy into organized radiation that's being used for some purpose we don't yet understand. In April 2025, Dr. Kevin Patel, an astrophysicist studying the Fermi bubbles, enormous structures of gamma-ray emission extending above and below the Milky Way's galactic plane, made a startling discovery connecting these features to the pulsing black hole phenomenon. The Fermi bubbles were discovered in 2010 by NASA's Fermi Gamma Ray Space Telescope. These massive structures, each spanning 25,000 light-years, extend perpendicularly from the galactic center like two giant bubbles inflated on either side of the galaxy's disk. Their origin has been debated. Most theories involve massive energy releases from Sagittarius A millions of years ago. I was analyzing recent Fermi data when I noticed the bubbles are changing, Dr. Patel reported. Not the slow evolution we'd expect from an ancient structure, but rapid changes synchronized with Sagittarius A's pulsing behavior. Each time Sagittarius A pulses, the Fermi bubbles respond. Brightness increases ripple through the bubble structure, traveling outward from the galactic center at nearly the speed of light. The bubbles aren't ancient static remnants. They're active structures being continuously energized by the central black hole. It's like watching someone breathe, Dr. Patel described. The black hole pulses, and the bubbles expand and contract in rhythm. Whatever created the Fermi bubbles is still operating, still pushing energy into these enormous structures. But why? What purpose could these cosmic structures serve? Dr. Torres proposed a radical interpretation. If you wanted to send a signal that could be detected across intergalactic distances, you'd need enormous power and enormous scale. The Fermi bubbles, energized by a pulsing supermassive black hole, would be visible to any civilization with gamma-ray telescopes across millions of light years. They're like a lighthouse, a beacon announcing the Milky Way's presence. This interpretation suggested the black hole pulsing wasn't just communication between black holes, it was communication meant to be detected by external observers. A signal saying, intelligent activity here. In May 2025, Dr. Vasquez's team achieved a breakthrough in decoding the mathematical sequences transmitted by the pulsing black holes. Hidden within the complex patterns were what appeared to be spatial coordinates, three-dimensional positions defined using a reference frame based on galactic structure. We're seeing repeated sequences that encode angles and distances, Vasquez explained. The angles reference the galactic center and galactic plane, a coordinate system that would be recognizable to any civilization in our galaxy. The distances are given in units that correspond to fundamental physical constants, specifically the wavelength of the 21-centimeter hydrogen line, multiplied by powers of 10. The 21-centimeter line, the radiation emitted when hydrogen atoms flip their electron spin, is one of the most fundamental frequencies in the universe. Hydrogen is the most abundant element, and this transition is identical everywhere. Using it as a universal measuring stick makes sense for any communication system intended to be understood across civilizations. The coordinates pointed to specific locations within the Milky Way galaxy. Dr. Torres plotted them on galactic maps, expecting they might indicate planets, stars, or other astronomical objects of interest. What she found was more puzzling. Most coordinates don't point to any visible objects. They mark locations in apparently empty space, interstellar voids with no stars, no gas clouds, nothing we can detect. But three coordinates did correspond to known objects: Sagittarius A itself, the source of the transmissions, a dense star cluster 12,000 light-years from the galactic center, a region in the Orion Arm, just 1,400 light-years from Earth. The fact that one coordinate points so close to Earth can't be coincidental, Dr. Chen stated. Either these transmissions are specifically addressing our location, or they're marking locations throughout the galaxy where something significant exists or will happen. Telescopes were immediately directed toward the Orion Arm coordinates. Initial observations detected nothing unusual, no anomalous radiation, no unusual stellar activity. but the coordinates were precise to within 1 light-year, suggesting something specific existed at that location even if we couldn't detect it yet. Throughout summer 2025, the black hole pulses continued to intensify and accelerate. By July, pulse rates had increased. Sagittarius A's 22-minute period shortened to 19 minutes, then 16 minutes by August. All 47 black holes showed proportional acceleration, maintaining the mathematical relationships between their individual periods. Dr. Webb projected the trend forward. If the acceleration continues at the current rate, all pulse periods will converge on a minimum value in late September 2025. The periods can't decrease indefinitely. Relativity imposes limits based on how fast matter can orbit near the event horizon. The black holes are approaching this physical limit. The date of convergence, September 23, 2025. It's like watching a countdown, Dr. Doleman said. Whatever this phenomenon is building toward, it reaches its climax in September. The black holes are synchronizing not just in their mathematical relationships, but in absolute time. As September approached, additional anomalies appeared. Several of the 47 black holes began emitting not just radio waves, but also X-rays, gamma rays, and even tentative gravitational wave detections, ripples in space-time itself. We're seeing electromagnetic emissions across the entire spectrum simultaneously, Dr. Chen reported, and the gravitational wave detectors at LIGO and Virgo are picking up signals that might, and I stress might, correlate with the black hole pulses. If confirmed, it means these black holes are manipulating space-time itself in rhythmic patterns. Gravitational waves travel at the speed of light and carry information about massive accelerating objects. If black holes were generating pulsed gravitational waves, they would be creating ripples in the fabric of space that spread throughout the universe. Imagine dropping pebbles in a pond at regular intervals, Dr. Malhotra explained. The ripples spread outward in concentric circles. Now imagine 47 ponds across the Earth, all creating synchronized ripples. Eventually, those ripples would interfere, creating complex patterns where they met. That might be what's happening with space-time. 47 black holes creating gravitational wave patterns that interfere and interact across the universe. In August 2025, Dr. Lisa Morrison, a dark matter researcher at MIT, proposed a connection between the pulsing black holes and dark matter, the mysterious substance that comprises 85% of all matter in the universe but has never been directly detected. We know dark matter exists because of its gravitational effects, Dr. Morrison explained. Galaxies rotate too fast to be held together by visible matter alone. Galaxy clusters show gravitational lensing far stronger than visible matter can produce. But we've never directly detected dark matter particles despite decades of searching. Morrison suggested that supermassive black holes might interact with dark matter in ways we haven't considered. Black holes don't discriminate. They attract everything gravitationally, including dark matter. If dark matter particles accumulate around supermassive black holes and those particles have properties we don't understand, they might be involved in the pulsing behavior. Her hypothesis gained support when sensitive gravitational measurements around several pulsing black holes showed anomalies consistent with dark matter density fluctuations synchronized with the pulses. It looks like dark matter is being organized into patterns around these black holes, Morrison reported, not just falling in randomly, but structured, like iron filings aligning with magnetic fields. If the black holes are somehow manipulating dark matter, it could explain the enormous energy outputs we're seeing. This raised a tantalizing possibility. Perhaps the purpose of the black hole network isn't communication at all, but dark matter manipulation. If some intelligence had learned to control dark matter, to organize it, move it, or extract energy from it, supermassive black holes would be the ideal tools. Dark matter dominates the universe's mass, Dr. Webb noted. Any civilization that could harness it would have access to energy and resources dwarfing anything available from ordinary matter. The pulsing black holes might be infrastructure for a dark matter economy we're only now beginning to detect. As September 2025 approached and speculation intensified about what might happen on the 23rd, a fierce debate erupted about whether humanity should attempt to respond to the black hole transmissions. Dr. Vasquez argued for sending a deliberate signal. If these transmissions are meant to be detected and understood, remaining silent might be seen as lack of comprehension or interest. We should respond with our own mathematical sequences, demonstrating that we've understood the messages. But others urged extreme caution. Dr. Stephen Hawking famously warned that advertising humanity's existence to potential alien civilizations could be dangerous. If the black hole network represented technology used by advanced civilizations, drawing attention to Earth might have unpredictable consequences. We don't know who or what is behind this phenomenon, Dr. Chen cautioned. Making ourselves visible could be the most consequential decision in human history. We need international consensus, not unilateral action by individual research groups. The debate reached the United Nations, where member nations struggled to formulate policy. Some argued that the decision affected all humanity and required unanimous consent. Others contended that any nation or organization with a technical capability should be free to respond. While diplomats debated, several private groups took action. On September 1st, a coalition of radio astronomers transmitted a response toward Sagittarius A, mathematical sequences designed to demonstrate human understanding of the black hole messages. The transmission included confirmation of the mathematical constants encoded in the black hole signals, Earth's position within the galaxy using the same coordinate system, basic information about human biology and civilization, a request for clarification about the purpose of the black hole network. The transmission would take 26,000 years to reach Sagittarius A at light speed. But if the black holes were quantum entangled, as some theories suggested, the message might be received instantaneously. As September 23rd dawned across the Earth, telescopes worldwide pointed toward the 47 pulsing black holes. The Event Horizon Telescope, coordinated globally, prepared for continuous observation. Amateur astronomers set up radio receivers, hoping to detect the convergence event with their backyard equipment. At 11:47 UTC, the pulses from all 47 black holes suddenly synchronized. For the first time since the phenomenon began in February, every black hole pulsed simultaneously, one universal rhythm instead of 47 individual periods. The synchronized pulses lasted for 37 minutes. During this time, the amplitude increased exponentially. Sagittarius A house became brighter in radio waves than it had ever been observed. The energy output from all 47 black holes combined exceeded the luminosity of entire galaxy clusters. Then, at 12:24 UTC, the pulses stopped. All 47 black holes returned to baseline emission levels simultaneously. The cosmic concert ended as abruptly as it had begun. Dr. Doleman's team scrambled to analyze the final transmission. During those 37 minutes, the black holes transmitted an enormous amount of information. The data volume exceeds everything they'd transmitted in the previous 7 months combined. The final message was still being decoded as of October 2025, but preliminary analysis revealed several components. Stellar cartography. Detailed maps of hundreds of star systems within 10,000 light-years of Earth, with specific stars highlighted, possibly indicating locations of interest or habitable planets. Physical constants. Precise values for fundamental constants of physics, but with subtle differences from the values we measure in our laboratories, as if showing what these constants would be in different regions of space-time or under different physical conditions. Geometric patterns. Complex three-dimensional shapes that some researchers interpreted as schematics, possibly designs for technologies or structures. Temporal markers. Sequences that appeared to encode specific dates using astronomical events as reference points. Several dates fell in Earth's near future: November 2025, March 2026, and August 2027. The temporal markers are particularly intriguing, Dr. Torres noted. They seem to be indicating when something will happen, possibly when we should observe specific coordinates or when certain conditions will be met. In the weeks following September 23rd, the pulsing behavior didn't resume. The 47 black holes returned to their pre-2025 activity levels. Occasional random brightening from normal accretion processes, but no organized pulses, no mathematical transmissions. It's as if they completed their task and shut down, Dr. Chen observed. The 7-month transmission was a complete package, beginning, middle, and end. Now we're left to interpret what it meant. Several developments suggested the story wasn't over. On October 7, 2025, a previously unknown near-Earth asteroid was discovered, designated 2025 TB-145. Its orbit was unusual, showing characteristics suggesting it wasn't a natural asteroid at all, but a dormant spacecraft in a stable orbit that had positioned it near Earth for thousands of years. The orbital parameters match one of the coordinate sets transmitted by the black holes, Dr. Malhotra noted. It's as if they were saying, "Look here," and when we looked, we found something artificial. On October 19th, SETI researchers detected a brief radio signal from the direction of one of the star systems highlighted in the black hole transmissions. The signal lasted only 14 seconds, but its structure matched the mathematical patterns from the black hole messages. "It's like a relay," Dr. Vasquez suggested. The black holes broadcast the initial message. Now other sources throughout the galaxy are responding or amplifying it. We might be witnessing the operation of a galactic communication network that's been here all along. We just didn't know how to recognize it. On November 3rd, 2025, gravitational wave detectors recorded an unusual signal, not from colliding black holes or neutron stars, but a persistent background hum at specific frequencies. Analysis showed the frequencies matched harmonics of the black hole pulse periods from earlier in the year. Space-time itself might be ringing like a bell, Dr. Morrison proposed. The black holes set up standing gravitational waves in the fabric of space. Even though the pulsing has stopped, the waves they created might persist, propagating through the universe for years or decades. The awakening of 2025 has transformed our understanding of black holes from simple gravitational wells into something far more complex and perhaps far more purposeful. 47 supermassive black holes spread across billions of light years activated in near-perfect synchronization, transmitted mathematical messages using universal constants, and then fell silent after delivering what appears to be a complete information package. Were these transmissions natural phenomena? Some previously unknown astrophysical process that produces organized signals through exotic physics we're only beginning to understand? Or were they artificial? Evidence of technology so advanced it uses black holes as communication nodes in a galaxy-spanning network? The evidence points increasingly toward the latter. The mathematical precision, the information content, the apparent coordination across vast distances, and the temporal markers pointing to specific future dates all suggest intent and intelligence rather than random physical processes. If intelligence is behind the black hole network, the implications are staggering. It means civilizations can manipulate objects with masses of millions or billions of suns. It means quantum entanglement can be exploited at cosmic scales to enable faster-than-light coordination. It means the galaxy is far more interconnected and far more artificial than we ever imagined. The 2025 transmissions might represent first contact, not with biological beings traveling in spacecraft, but with intelligence so advanced it operates through the manipulation of space-time itself. Intelligence that uses black holes the way we use radio towers. Intelligence that thinks on galactic scales and communicates across billions of light years as casually as we send emails. Or perhaps the awakening wasn't about contact at all. Perhaps it was a demonstration, a proof of concept showing what's possible when you master gravity, quantum mechanics, and the fundamental structure of the universe. A message saying, this is what intelligence can achieve if it survives long enough and thinks big enough. The temporal markers in the final transmission suggest we haven't seen the end of the phenomenon. Something is scheduled for November 2025, March 2026, and August 2027. Whether these represent additional transmissions, observable events, or something else entirely remains unknown. What we do know is that black holes are not what we thought they were. They're not just cosmic vacuum cleaners mindlessly consuming everything that falls into them. They're potentially nodes in a network that spans the observable universe. They're possibly tools used by intelligence far older and far more capable than our own. And they're apparently active, operational, and engaged in processes we're only beginning to detect. The universe revealed in 2025 is stranger and more purposeful than the random, mechanistic cosmos we thought we inhabited. It's a universe where supermassive black holes can be coordinated like instruments in an orchestra, where quantum entanglement links objects separated by billions of light years, where mathematical messages are written in the pulse patterns of cosmic titans, and where intelligence might operate at scales so vast that galaxies themselves become the units of organization. Humanity has received a message from the deepest gravitational wells in the universe. We've documented it, analyzed it, and begun to decode it. But understanding what it really means, understanding what black holes have become, and what purpose they serve will likely occupy scientists for decades or centuries to come. The awakening of 2025 has opened our eyes to possibilities we'd never considered. The question now isn't whether we're alone in the universe. The coordinated behavior of 47 black holes suggests we're not. The question is whether we're ready to understand and eventually participate in whatever cosmic system we've discovered. The black holes have spoken. They've delivered their message. And now they're silent again, waiting. Whether they're waiting for a response, waiting for the dates they specified, or simply waiting for humanity to understand what we've been told remains the greatest mystery of our time.